Hello, everybody. Welcome to the Filamentous webinar, How to Inspect Your FRP Emission Control Equipment. We are going to just wait here a couple more minutes and just allow a few more of our people to register in and just get signed in, and we'll get started in a couple minutes. If you have any questions in the meantime, there is a widget down on the bottom that you can take a look at, so please feel free to click on that and type in your question. All right, everybody, I think we're going to get started here. Again, just want to thank you all for attending today. Want to start with a little bit of housekeeping first, just in case you are not familiar with the webinar platform that we are using. Just want to kind of go over a couple things. And if you take a look at the screen that's being shown right now, it's basically just a copy of what's already on your screen. And there's actually the option of basically taking these windows and expanding them or reducing the size of them as well. So if it's a little bit small, you can take it out and make it larger. If it's too big, you can make it small. You can minimize, you can expand, whatever works for you. Along the bottom are little icons, and they're called widgets. And they're basically some options for you to do here while you're on the webinar. The first one is your media player, which is how you are getting the sound. You do want to keep that on at all times. If you should happen to lose any of this, you can basically go down to the icons and pop them back up. You can also control the sound level there. The next icon over is the Q&A. At any point in time during the webinar, if you have a question, please feel free to post it. And if we're able to, we'll push it up right away and answer it, or we will answer it at the end. But we do encourage you to post any questions while you have them. The next widget over is the slides widget. If for any reason your presentation gets minimized, you can't find it, just click on that widget and you will be able to expand it again. Next widget over is just your general help widget. If you're having any problems, technical, you can click on that for your answers. Little light bulb is the idea widget. If as you're going through the presentation you have an idea and something you want to throw out there, we'd love to hear from you, so please feel free to post it while you think of it. Next widget over, the green one, is basically the share. If you feel there's something important there that you want to share on any of your social platforms, LinkedIn, Facebook, Twitter, all that, you can move that forward. The next widget is the resources widget, and basically it shows the list up here of all the resources that are available to you. You can take and click on any of the above PDFs and download those files directly to your computer. This presentation as well will be available afterward. It is being recorded, and all of the functionality stays the same. So basically you will still be able to come back and grab any of those resources even if you come back at a later time. The next widget is LinkedIn. If you want to log in and get your news feed and then share anything, you can do that. The one after that is the poll widget. The poll widget will automatically come on at the end of the webinar, but you're more than welcome to start filling it out at any point in time. All you need to do is click on it. If you'd like to tweet during the webinar, please feel free to. You will need to log in with your credentials, but you can do so. And then finally, the last widget is the Verantis icon swirl, and that will actually take you directly to our Verantis website. So if at any point in time you need to take a look at something on there, please feel free to do so. Our first presenter is going to be Jay Janning. He is our Director of Aftermarket, and he is going to start us off.
Thank you, everyone, for joining us today. Today we're going to be discussing the topic of aftermarket products and support. The topics that we're going to discuss today is how we inspect FRP equipment, how often we should replace packing, during maintenance, what additional things should be inspected or replaced, and finally other services offered by Verantis. A brief overview of some of the product lines that we have here. A lot of people are familiar with our FRP exhaust fans. We also have an ionized wet scrubber, our IWS system, which is a special Verantis trademarked piece of equipment. Pack towers, we have a wide variety of scrubber systems. We can do pre-engineered systems, filtered systems, also very customized systems depending on the needs of a customer. New additions to our product line a few years ago, we acquired some technology that includes thermal treatment, includes rotary kilns, incinerators, and thermal oxidizers. We can always be available for questions or visit our website for more detailed information on these products. To start things off, we're going to start with a poll question. We'll give you maybe about 20 seconds or so to look at this. We have a few poll questions that are mixed in throughout the presentation. First is we would like an idea of how often you inspect your equipment. And I'll just pause here briefly to let you answer that. All right, let's see what the results here are. Close to half once a year. Good to see people are looking at their equipment more than once a year, 3 times. And looks like we have a few people that aren't sure what to inspect. So the first segment of the presentation I'm going to turn over to Junior Hardman. He's our plant manager at our manufacturing facility. Junior's been with Verantis about 38 plus years or so. Junior?
Hi, this is Junior Hardman. First thing we're going to talk about is FRP inspections and the types of damage you see. The first one will be chemical attack. The next one will be heat distortion, abrasion, mechanical abrasion, and UV damage. This first slide is the inside of one of our small fan housings that was returned, and inside that housing it had a carbon gel coating on the interior. You can see that there's part of the carbon gel interior missing. We also have exposed glass fibers. We inspected that and determined it was caused from possibly particulate erosion and chemical attack. This next slide is the impeller that came out of that fan. Again, you can see the black carbon gel. Over here you see the exposed glass fibers. You can also see the yellowing and discoloration caused from the chemical attack. This is showing the blade of a club impeller that has severe heat deformation. Heat deformation can be caused basically from 3 things. The first and foremost is your process temperatures. If there's an upset of the process temperature gets too high, you'll see that this also, if you have a mesh pad mist eliminator before or after the housing, that can also cause heat distortion, or running the fan with closed dampers. And this heat deformation not only pertains to the fan, but it can also cause detrimental damage inside the scrubbers and ionizers. This is a picture of the same impeller. It's at the OD where the blades are strapped together. And what happens when the heat rises, the fiberglass starts to soften. The fan's running, you have centrifugal force that starts moving the blade outward, and then it will start tearing here in the corners at the strap joints. This one here, this photo shows buildup. Buildup, if it remains uniform and doesn't come off in large chunks and pieces, really doesn't affect your vibration levels too much. But when you have material starting to come off and the fan goes out of balance, you reach a certain point where the fan is seeing stresses and forces that it's not normally meant to see, and you'll start seeing fatigue cracking. Cracking is no different than taking a thin piece of steel, flexing it multiple times, and eventually it's going to crack. Fiberglass does the same thing. This photo shows abrasion. It could be particulate in the system, or it could be moisture causing the abrasion along the leading edge of the blade. The gel coat's coming off and exposing the glass fibers. Once they're exposed, now you're subject to chemical attack as well. This slide shows an impeller that has contacted the inlet cone here, and you can see where it has rubbed. What normally happens with that, something has moved, whether bolts on the housing, mounting it to the base have loosened up and let it shift, or in the case of this fan, it had a bearing failure. When the bearing fails and you have a belt drive unit, the bearing is pulled off to one side, which in turn moves the inlet closer, or the impeller closer to the inlet cone, causing the rubbing you see in this area. This is a picture of ductwork that has a top coat on it with ultraviolet inhibitors in it. It's been outside probably 10 years, and you really see no problems with it. You don't see any glass fibers, so it's been well protected from the UV. Here's a picture of another piece of duct that never had the UV coating. You can see the glass fibers, and you can see the resin exposed. This is a picture of one of our dust collector fans that's been in service since 1977. This fan's only probably been taken out of service 2 times in the last, 37, 38 years and been rebuilt. Also, if you look right here, you can see a white line. That white line is actually where the top coat over time has weathered and worn away, and its glass fibers starting to show. Here's a close-up of that same photo. You can see the glass fibers that are exposed.
All right, we have a question, so Mary's going to push a question up to the front.
Are these all Filamentous fans?
Are these all Filamentous fans? Yes, they are. That's an easy question to answer. All right, thank you, Junior. We have a poll question we're going to go to now. How often do you perform routine maintenance or planned shutdowns in your facility? Again, I'll give you about 15 seconds or so to answer this one. All right, and for our results, quite a few annual, quarterly, and 25% only when it breaks. We're going to pass the next segment over to John Tonkowitz. Oh, we have another question. Hold on one moment.
Before we move on, we have another fan question that we'll push up here. What can cause excess chemical precipitation inside a fan that treats H2S in wet chemical scrubbers?
Yeah, this is John Tomkowitz. H2S in and of itself isn't going to cause precipitation. Okay, it's going to stay in the gas phase as it passes through a fan. If you have a fan downstream of an H2S scrubber and you're getting chemical precipitation on that fan, it's probably a result of the reactant chemicals, sodium hydroxide and sodium hypochlorite, that are being added to the system to scrub the H2S. And if the concentration of those chemicals are not being controlled properly, where you have excess amounts of those chemicals, then if there is any small amount of carryover from the scrubber to the fan, that could result in deposition of salts on the impeller blade. The other thing would be, even if you have your system in balance and your entrainment separator is not operating properly, either it's fouled or out of place, allowing some bypass, then that same liquid solution that's in the scrubber that contains those chemicals can be exiting out through the scrubber, through the duct, and into the fan, and throughout that whole area, just with evaporation, there'll be a drying and build up of materials on the impeller.
We have another question as well. Can dry glass or exposed fibers simply be wet down again by applying new resin?
Now, this is Junior Hardman. No, it cannot, because the biggest problem you're going to end up with is you have chemicals already in the glass and potentially on the resin, and you're not going to get good secondary bonding, and eventually it's going to peel right back off.
Okay, move back on.
Okay, good afternoon, everyone. This is John Tomkowitz. We're going to talk a little bit about pack scrubbers, specifically packing itself, and the first slide, I wanted just to present the basic definition of what the packing is for in the scrubbers. It's designed to promote the intimate mixing of the scrubbing liquid and contaminated gas in a very small contact zone to allow absorption and or reaction of the gaseous pollutants with the scrubbing liquid. What a lot of people that aren't involved in scrubber design don't realize is that the average contact time for the gas inside a pack scrubber is about 1 second, sometimes less. The gas is passing through very quickly. In that 1 second of time, we're trying to get high degree of efficiency, 99%, sometimes 99.9 or even 99.99. So the proper condition of the packing is very critical to the scrubber performance. So there are a number of critical operating parameters for optimum performance of the pack section. Typically, most scrubbers will have some measurement of packing pressure drop. That's an indication of the pressure loss from the inlet gas to the outlet gas due to the packing, due to the airflow passing through the packing. High delta P indicates a problem, and that's most typically due to some type of fouling. We'll talk about types of fouling in a few minutes. Recycled liquid flow needs to be at a constant rate. Should always be at or slightly above the specified design rate to make sure that we have the proper liquid to gas ratios. Uniform liquid distribution, very, very important, because non-uniform liquid distribution can result in dry areas in the packed bed where you have, or possibly areas where you just have low liquid to gas ratio. So then again, the liquid and gas aren't being in contact as optimally as possible, and that can reduce scrubbing performance. Chemical feed rates, not all, but most scrubbers require different types of reactive chemicals such as acids, bases, oxidants, reducing agents. And in the case of having too little chemical, obviously, then you don't have enough reactant to remove the contaminant gases, so that can reduce performance. In the case of too much chemical, that can also cause problems because then you can get other types of reactions occurring that can cause chemical scaling and fouling inside the system. So it's critical that the chemical feed rates, the concentrations in solutions be properly maintained with various analyzers such as pH control, RP control, conductivity control. And lastly, makeup water and blowdown rates. As much as people would like to have scrubbers designed with no water usage and no discharge usage, it's not possible. You have to be able to remove a small amount of the contaminants that you're producing depending on the application. And the way that's done is by adding makeup water to the system. The makeup water also helps adjust for evaporative losses if the gas that's coming into the scrubber is not fully saturated. So the key component areas to look at in a scrubber design when doing an inspection are the spray nozzles or liquid distributor if it's a different type of distribution system. Again, this needs to provide adequate, even distribution of the liquid across the packing surface. The main pack bed that provides the highly turbulent contact zone to facilitate the efficient absorption. So again, that needs to be clean and free of any type of particulate and fouling. The mist eliminator above the section is important to make sure that entrained droplets are not carried out of the system. Someone had previously asked the question about buildup downstream on their fan, and that could be a reason why that's occurring if that mist eliminator is not functioning properly. And then lastly, the collection sump, the reservoir at the bottom, that provides the liquid for the recycle to the scrubber. So it's important that that be maintained in a clean condition so that any type of solids or material that builds up in that sump is not causing any restrictions to the pump suction, which could inhibit flow to the recirculation pump and then cause lower liquid flow to the packing itself. So 3 reasons for packing replacement are typically fouling of the packing that cannot be cleaned in place, chemical degradation of the packing, and thermal damage of the packing. Those are the 3 typical problems that we see that require packing replacement. So there are a number of reasons that fouling could occur. Insoluble solids is a major one when you have particulate matter in the inlet gas. So this is not something being created in the scrubber. It's actually coming into the inlet gas. Pack scrubbers are not designed for high loadings of insoluble solids. There's different types of equipment that's designed for removal of solids. They will remove them, but the problem is they can remove them down to approximately 10 micron. But again, they will impinge inside the packing and over time build up and cause fouling and pressure drop increases. Another situation is hydrolysis of certain contaminants. There's a number of contaminants that when they react with water and water vapor, they form insoluble solids. A good example of this is of chlorosilane materials, which when they react with water vapor, they form hydrochloric acid, which will be scrubbed in the pack tower, but they also form SiO2 particulate, which is totally insoluble and will foul the pack tower. So again, if you have a situation where your process has changed and now you have contaminants of this type, or you have solid particulate at a higher concentration than expected, then you might need to look at some type of upstream equipment to filter that material out before it reaches your pack tower. The next one is precipitation of reaction byproducts. Most of the reactions that involve chemical addition result in byproduct salts. All of these salts have different solubilities. The most common that in the industry is the reaction of hydrochloric acid with sodium hydroxide to produce sodium chloride. The sodium chloride is very soluble, 25% by weight, but at the same time, if you exceed that solubility limit, you will get precipitation, and that precipitation can plug the packing. The third following possibility is chemical scaling. The most common is carbonate buildup, and this can be caused by two sources. One is if you're operating a highly alkaline system, maybe you require an elevated pH for scrubbing of something like chlorine, for example. At elevated pH, with using sodium hydroxide, the scrubber will actually not only remove the chlorine, but it'll actually start scrubbing the carbon dioxide that's right out of in the gas itself. That can either be in ambient air, which is at low concentration of about 330 part per million, but in applications where you have a combustion process up front, the carbon dioxide levels can be even higher. So if that occurs, you can get sodium carbonate formation, which will cause a white crystalline scaling on the packing and start fouling the packing. Sodium carbonate is something that has some solubility, and also that typically can be removed with scrubbing with an acid from time to time for cleaning the scrubber. The other more serious problem is when you have very, very hard water. In that case, you're going to have calcium, not sodium, and calcium carbonate is extremely insoluble and very difficult to remove once it precipitates to any great degree. So if you typically when scrubber systems have very, very hard water, we recommend that water softening be used to minimize the amount of scaling inside the tower. And the fourth possibility is bacteriological growth. This can be triggered by the presence of various chemicals that are coming in the inlet gas. Typically, they're organic compounds. Organic compounds in an alkaline environment tend to like to create it's just the right environment for bacteria to grow. And the problem with bacterial growth is that once it starts forming to a great degree, it's a very slimy, sticky residue which is on the packing. You can kill the bacteria, but it's very, very difficult to remove from the packing. It's very hard to scrub or recycle liquid that'll take that growth off once it's occurred. So if the conditions are right for this type of situation, or if you experience this type of situation in your system, the recommendation would be to you start adding small concentration of a biocide to prevent that bacteriological growth from occurring. Next possible reason for packing damage is chemical degradation, embrittlement, softening, discoloration, and thinning. For the basis of the discussion here, I'm going to use polypropylene as the material of construction. That's the most typical material of construction for corrosion-resistant packings. We offer other materials too, Kynar, CPVC, and some Teflon materials, but polypropylene, because it's the most economical, is the most widely used in the industry. Embrittlement, that can occur in the presence of strong oxidizing agents. Chlorine is an example. Concentrated nitric acid is another example. That doesn't mean that you can't use polypropylene packing for chlorine scrubbing. Many systems have that, but if you have extremely high concentrations of chlorine gas coming in for, say, an emergency scrubber or something like that, then in some cases people will consider going to a different material that won't have the embrittlement problem. But once basically what's happening is just an oxidation of a plastic, and I think we all know when you oxidize a plastic, it just gets harder and it can crack. You've seen it, sun oxidation that can damage plastic that's left outside. So that's basically what's happening inside a scrubber if you have the right chemical conditions. Softening, swelling of the packing is another thing that can happen. That's also related to specific chemicals. Normally for polypropylene, halogenated solvents, carbon tetrachloride, chlorobenzene, things like that, which actually tend to almost start dissolving the polypropylene itself. Discoloration can occur for a lot of reasons, and that's usually the first indication of some type of, if the discoloration is not due to an actual buildup of material on the packing, then it's a good first indicator that there is some level of chemical degradation that's occurring inside the unit, even if there's no other symptoms that are being observed. And then the last is thinning or dissolving. Again, there's certain organics that can cause this, aromatics such as toluene, and also very, very reactive gases such as fluorine gas, not hydrogen fluoride, but fluorine gas itself, F2, which can cause this kind of problem. Third category is thermal damage. We're dealing with plastic internals here. Obviously, they have limitations as far as heat exposure. First being deformation, and that excessive heat can come from a number of different areas. It can be from the upstream process itself if there's some type of upset condition that brings hot gases into the scrubber hotter than what it was intended to see. The second could be failure of upstream cooling equipment. Many of these systems are used downstream of thermal processes, oxidizers, incinerators, etc., and there's normally some type of cooling quenching system that's used upstream of the scrubber to saturate the gas below 200 degrees Fahrenheit. So if you have a failure of that unit for some reason, then you can have hot gases coming into the scrubber. The third is if you have an excessive contaminant load, something that wasn't really designed for the contaminant, can be creating a very, very high heat of reaction with the chemicals that are inside the scrubber. Discoloration, obviously, if you see any type of darkening of packing, polypropylene is typically a whitish, clear whitish appearance, and if that starts darkening, that could be that first indication that there was either some type of thermal upset or there's a periodic upset that's occurring. Excessive settling is really a result of the deformation we talked about for the first bullet point. As the packing is softened and starts deforming, then the packing bed itself is going to start settling. It's going to basically shrinking down. So what happens there is you're going to be decreasing the amount of open area in the packing, which is going to inhibit the flow of gas through the packing and increase the pressure drop. And secondly, the other problem with that is that if your liquid distributor is normally designed to put the packing at a certain point into the top of the tower, especially if you have spray nozzles, and if you don't have the correct packing height, more and more of that liquid spray will be put on the walls of the scrubber instead of contacting the gas in the middle of the scrubber. And with a lower liquid to gas ratio, that can result in reduced performance. I think Mary's indicating we have a question here, so do you want to bring that up, Mary?
What would be the cause for a white powder-like substance building up on conductivity probes? Is it most likely due to makeup, water source, or inlet, exhaust, or both?
Yes. That's a difficult question because I'd have to know a little bit more about the unit itself. But again, the sources that could be causing that are the actual chemistry in the scrubber itself, which could be a carbonate buildup, or it could be sodium carbonate buildup, or it could be a water quality issue, which is a calcium carbonate buildup. The key there is really how easily it's cleaned. If you can take that probe and you can clean it in a very dilute acid solution and the material comes off easily, then it's most likely sodium carbonate. If it doesn't come off as easily in that same solution, then it's probably related to water quality. As far as pack scrubber inspection, looking at the packing, there's really no fast and hard rule here. Recommended inspection frequency can vary from 3 to 12 months, and it really depends on the severity of the application. Or again, if it's triggered by some other indicator such as a high pressure drop indication, or you know that the scrubbing performance has been reduced, if you're monitoring scrubbing efficiency, or just based on odors or whatever, you can tell that the scrubber isn't performing as it should be. And to some degree, this is always going to be something that needs to be determined in the field by the client, because so many cases we'll have certain design specifications of contaminant loading for the original design, and then what we see out in the field is much, much different. Many times the initial designs are high contaminant loading, and the actual true contaminant loading ends up being much lower, which would then allow you to inspect much less. But the reverse can be true when the contaminant loading is 10 times higher than what was originally anticipated. And so to some degree, like I said, this is a guideline, but then it has to really be determined by your experience in the field. So those are the reasons for why you should consider replacing packing if you see any of these conditions occurring. So the next thing we were going to discuss is the types of replacement packings. The traditional style of packing is called an extended surface packings. Saddles and rings are two examples of that. This is a style of packing that really has been around for 70, 80 years in pack towers. It's provided by many different suppliers. It has a variety of different styles of configurations. The advantages of this type of packing is that they do work well with coarse liquid distribution. They have a lot of large flat surface area, so if you have like a poor distribution of liquid in your tower, these types of packings tend to spread that liquid out a little bit farther and more evenly across the surface area of the packing. There is also a disadvantage of that, and that is over time what they tend to do is push liquid towards the walls of the unit. They tend to migrate liquids out. So for very large packing depths, packings of this type normally have to have some type of mid-range redistributor to take the water off the walls and put it back on the packing again. The disadvantages of this style of packing is, again, these are older style packings. They have much higher pressure drops than the more modern styles of packing, which we'll talk about in a minute. And they also have lower efficiency for a relative amount of pack depth. Filamentous packings, that's really the most current style of packings that are used in most applications for scrubbing. They've been developed over the years to try to minimize pressure drop, which correlates to energy usage. Everyone is always trying to minimize the amount of power that they use and energy costs, and at the same time improve mass transfer to get higher efficiency removals, because again, over the years what has occurred is the regulatory requirements have gotten stricter and stricter, where people are trying to get much higher efficiencies in their scrubbers. The style of filamentous packing that Verantis offers is the Telluride tower packing. This actually is the original filamentous packing that was developed back in the 1960s. That would be the type number 1, the small spiral, shown towards the middle left there. And then at the same time, over the years, we have a number of different styles that we have designed and developed, again, trying to improve this concept of reduced pressure drop and higher efficiency at the same time. And that's what our K series represents, the 2K and 3K packings. The advantages of the filamentous type packings, they definitely have lower pressure drop, higher efficiency for a given pack depth, and therefore they have lower relative cost than the extended surface packing. So if you look at packing in bulk, extended surface packing cost per cubic foot is actually going to be lower. But if you look at the relative performance, the height required, the diameter of the scrubber required, things of that nature, then the filamentous packings definitely have the lower total cost. The only real disadvantage is, again, these are filaments, and so they don't have a lot of flat surface. So you need to make sure that you do have pretty good liquid distribution on top of your scrubber to make sure that the liquid is uniform across the whole surface area. In cases where scrubbers, if you're looking at replacing packing in a scrubber that already has extended surface and say maybe just has a wear trough distributor, that doesn't mean you can't use Telluret packing. What we would recommend in those cases is that you would use Telluret packing, but maybe for the top 6 inches of packing, we would put a small layer of the saddle style packing on top, and that would give us help us redistribute the liquid, but then at the same time give you the advantages of using the filamentous Telluret packing in the tower. So this is a comparative curve. I know it's a little bit hard to read. What it is it's the height of a transfer unit versus gas rate for scrubbing SO2 from an airstream using caustic solution. And the green, blue, and red are comparative curves of green being the Telluret packing, blue being the tri-pack, and the red being the saddle packing. HTU is the height of a transfer unit, and in this case, the lower the number, the better. And what you can see here is that the Telluret packing actually provides better performance than both the filament style tri-pack and much better than the extended surface packing. To give you an example, again, I apologize, it's hard to read, but if you look at the gas rate at approximately 2,000 per hour per square foot and a liquid rate of 4,000 pounds per hour per square foot, the Telluret system to achieve 99% efficiency would be about 6.4 feet of packing. Tri-pack would be 8.8 feet of packing, and the saddles would be almost double at 12.5 feet of packing. So the Tellurets are going to provide you the optimum performance for both pressure drop and for mass transfer. If you're replacing a fixed pack bed, what that means is you're going to get higher efficiency. You can get higher throughput if your process requires more flow, and it just gives you a lot of options for replacement.
And actually, just to add here, this graph and others are actually available over on the resource list. If you look at Telluret tower packing technical data, you can always download that and get a better view of it later on.
Yeah, this particular curve is 12-10.81 for reference. Can't really read that from the slide, but if you want to go and look at this more closely, as Mary said, you can look at our resources and check this curve out. And then the last slide I have up here, I put up because it represents a comparison of pressure drop and efficiency. Most curves that you're going to see for packings out in the marketplace, they'll show you efficiency versus gas rate. They'll show you pressure drop versus gas rate, but you won't see the comparative differences, because the two critical parameters, again, for design of a pack tower are you want low pressure drop, which equates to low energy usage, and you want high efficiency in a small contact zone. So when you plot these out for, in this case, this is a comparison of the 2K, 3K Telluret versus the other styles of filamentous packing, the tri-pack and the land pack. You can see that for a given efficiency, the Telluret K packings, both styles will actually provide you the lowest relative pressure drop for that same efficiency. So either if you're designing a new tower with this material or you're replacing packing in an existing scrubber, one thing that you can be assured of when you make the replacement is that you're going to achieve at least the performance that you have for other styles of packing, and basically you're going to actually achieve better performance. So you can have the confidence that by replacing the packing with the Filamentous Telluret 2K, you're not going to have any issues or violate any permit regulations that you're currently bound by. And that's all I had on packing replacement, so I guess pass it back to Jay. Jay's going to talk a little bit about other tower internals.
All right, thank you, John. Poll question here before we kick off. This is our third one we have. Do you have critical spares on hand, for example, long lead time items? Anything that would need to be replaced quickly, but would take a long time to either manufacture or purchase? And the poll results. Some items and kind of a mix of yeses and nos there. So I'm going to talk firstly about maintenance. We kind of discussed, packing. John went through some different reasons for inspecting or replacing packing. I'd like to just kind of give an idea, other than FRP equipment, what are some of the things you'd want to consider, both with scrubber systems, also with fans, and identify some of the consumable parts that you'd want to consider replacing or inspecting during maintenance. Packing support plates are literally just that. They sit at the base of the packed bed. Typically, these are polypropylene, and for the same reasons John described with packing, these will degrade over time. Spray nozzles, which are used for liquid distribution. The little pigtail ones, as you can tell, those are typically made of Teflon or even a similar material. Those can, over time, become brittle and break. Entrainment separators or mist eliminators, there's 3 different types I'll talk about. These sit, again, above the liquid distributor. We have, in the past, designed unirrigated packing using our number 1 artillery. As the mist is carried up into the top of the scrubber by the airstream, the droplets collect on the tellerets and form larger droplets, which then allow gravity to do its job and, remove them down. Second type is mesh pads. These are most common. We see a lot of polypropylene or stainless steel. These do require frequent inspection to avoid fouling. Third type, which is very common for us here, is a chevron-style blade. These can be manufactured out of either FRP or stainless. We can also manufacture out of, high nickel alloys if needed, depending on the situation. The orientation for these is really important. Both the pictures on the left and on the right show the orientation of the hooks downward. The little bubbles there, or dots, represent the water that's being carried up in the airstream. These are much less likely to foul like a mesh pad, although the little hooks that are in there can develop a buildup of materials. So these should also be part of the routine maintenance and inspection to make sure that they're performing properly and there's not too much buildup inside the hooks. During routine inspection and maintenance for systems, the strainers should be checked weekly, cleaned as needed. Spray nozzles for liquid distribution quarterly. They will get clogged with material. The sump itself can see a buildup of solids. It's also possible, if you have problems with the packing over time, the packing can break up and fall through the packing support plate and then clog up the sump. The packing level itself, frequently scrubbers will have an inspection port near the top of the scrubber that can easily be opened and just check the level. Again, John kind of discussed the reasons for keeping a proper level. And then the entrainment separators semi-annually, checking for buildup and clean as needed. Some processes actually might require cleaning a little more often. It would depend on your process and throughput. Last poll question we have for today is if you don't have an inventory of critical spares, what's the reason behind that? Cost, space, not needed, downtime isn't a big deal, maybe shut down every week, or upper management doesn't allow it in the budget. Results, wow, that was a little unexpected. We got an even 50-50 split between downtime isn't a big deal or it's not in the budget. It's interesting to know. For fan maintenance, left-hand picture is a nice brand new clean impeller with a shaft. On the right-hand side is an impeller that we got back, had excess buildup on it. You can already see some cracking there in between the hub and the blade. Also, in the top portion of it, right near, we put some numbers on there to identify it. There's a white chunk where you can see like an even break. It's a good example of where buildup occurred and then a piece of that broke off. And that leads to a lot of imbalance, as Junior was talking about earlier. Also, a big part of fan maintenance is the shaft bearings and the motor bearings need to be properly lubricated. With all of our fans that we supply, we do provide a maintenance lubrication schedule on the fan bearings, also information on the motor supplied. Different motors and different manufacturers will use different types of greases. The most common that we've seen out there is a lithium-based or a polyurea base. It's very, very important not to mix these two types of greases. Mixing them up will basically destroy the lubricating property in the bearings, ultimately leading to either a decrease in bearing life or a failure. Also, something as Junior and I were talking about, something as simple as keeping the grease gun, the tip of that cleaned. Sometimes they could be dropped out in the field and you don't think about it, gets picked up. But introducing dirt into the grease, into the bearing, will dramatically reduce the bearing life or ultimately lead to a failure of the bearing. So this was an example of a customer who wanted to try to save some money and replace one of the bearings themselves. Great thought in the front. What happened in this situation, the bearing on the left, closest to the fan, is the one that we originally supplied. There were two identical on there. This was a spherical bearing. That one happens to be a fixed bearing. The other one that's closer to the guard, the yellow on the right, was the expanded bearing. The customer took the right-hand bearing off, went and got a replacement bearing which was the same size. Not really knowing what they were doing, they actually put in a ball bearing instead of a spherical bearing, and they put a fixed bearing in instead of expanded. Very hard to tell the difference if you're unaware of the different types of bearings. Not having the expanded bearing on there won't allow for the thermal expansion of the shaft. Ultimately, what happened here is the shaft broke, as you see in the picture on the left-hand side. This ultimately led to a new impeller, a new shaft, new bearings, a new drive set, and there was damage done to the inside of the housing where the impeller started moving around on the inside of the housing. So up front, where they had the idea of saving a little bit of money, probably costed them 3 to 5 times more in the long run to fix that bearing. Routine maintenance and inspection on fans. During startup, it's recommended to check the belts, the bearings, tightening down the bolts after a few hours, after a day, a week, 2 weeks, and then after that monthly. Belt tension and alignment should be done monthly, tightened and adjusted as needed. The V-grooves in the belt will wear over at time and cause slippage. This can most easily be observed by belt dust building up underneath the belts or in the shaft guard. Ultimately, this will it might even be observed by a decrease in airflow in the system or by the fan. The impeller, monthly, and I put a little asterisk there because this is very process dependent. In a clean environment, the impellers will not see much buildup, or depending on the style of impeller. There are some processes that will clean out an impeller and start seeing a buildup within a week or 2 weeks. Dampers should be checked monthly as well for full functionality, making sure they're able to open and close completely. There are a lot of systems that have automated dampers that would involve motors or sensors. These should also be checked as well because it's very possible that, a motor can burn out, sensor goes bad, a damper could either close and remain closed or open and not close when needed and cause problems. And then bearing lubrication, that will vary. It depends a lot upon how often the fan is operating. Again, following the maintenance schedule is the lubrication recommendation is important. Then some of the other additional services that we offer at Filamentous, we do offer field service for either inspection or repair of equipment that can easily be repaired in the field. Some cases, we have fans that are returned to us to be repaired. We can help troubleshoot fans and systems. Sometimes this can be handled over the phone or email. Likewise, we can send someone out to, help inspect on site. For newer projects, we offer installation supervision, startup testing, and training of on-site personnel as needed. We also offer engineering studies. There might be changes in your process over time, or we can help to maximize or optimize your existing equipment to help you keep current with emission regulations or changing EPA requirements. I'd like to thank everybody for their attention. I'm going to open the floor up for discussions, and Mary will push up any questions that we have. I've also put my contact information here. I'm a great first line of defense for answering questions. I can also forward questions over to John Tonkowitz or to Junior as needed as well. So, Mary?
What is the relative cost difference between a carbon steel versus an FRP fan? Ralph, did you want to answer that one? Or?
Well, in general, carbon steel fans are less expensive. To what degree it varies based on the size of the fan. The critical thing in determining a steel fan versus an FRP fan is the corrosive environment and the airstream that the fan is operating in. Because although the metal fans, yes, they're cheaper, if you put them into the application, for example, that's a wastewater treatment, it becomes a throwaway fan. The metal fan becomes a throwaway fan, and it could do so in as short a time as less than 12 months. So you really want to take a look at not the first cost, but rather what is the best materials that the fan are constructed out of for the contaminants in the airstream.
Does Filamentous provide field support for repair of other FRP equipment?
Absolutely. I mean, aside from just Seal Coat or Filamentous equipment, certainly we can extend our expertise into anyone else's scrubber system or FRP equipment.
What is lead time for packing delivery?
Our Tellerant packing for the 2K and 3K, we keep about 2,500 cubic feet in stock.
In polypropylene.
Of polypropylene, yeah, thank you for clarifying that. Of the 1R, 2R, and 3R series, we keep about 500 cubic feet in stock. Lead time would depend on how much you want to order. We can manufacture about 625 cubic feet per day of the 2K and 3K, so if it's a large order, it just depends on how much you need. If we're talking about CPVC or Kynar or glass-filled polypropylene, we can also do polyethylene. Part of that lead time would be material. That can range from 3 to 5 days to get the material. And then manufacturing time would just be, scheduling our mold injection to run. Again, the lead time on the packing will depend upon how much packing's ordered.
Junior, can you talk a little bit about pressure washing the fans, since it's such a critical aspect of the maintenance, and we frequently get questions about, too much pressure, not enough pressure, how, why, when, all of the above?
Well, in my experience of pressure washing fans out in the field, I kind of recommend like a homeowner unit, not a big commercial pressure washer. You're probably looking at something around 2,000, 2,500 PSI to pressure wash the inside of fan housings and impeller. Again, you don't want to hold the wand in any one place for an extended period of time, because it will start taking the coating and eventually cutting the glass. So it's very, very important that you continuously move the wand. Don't get too close to the glass. And again, depending on what kind of buildup it is, some's going to come off easier than others.
Is it possible to get a copy of the slide deck? Absolutely. If you would like a copy of the PowerPoint presentation, either shoot me an email directly. I'm the one who sent the invitations out, so you have my email. Or you can also just shoot me a question here and tell me you want a copy, and I'll make sure that you get it. Everyone here will get a link here after the program with copy of the recorded version of this, so that will come to you automatically. But if you do want the PowerPoint itself, just feel free to email me or send me a copy here, a question here directly on this webinar presentation. I'll make sure that you get it. And I think that's about all the time that we have for today, but if you have any additional questions, you can continue to shoot over questions via the webinar, and they will make it over to us. Or you can contact us directly, and we will definitely get back in touch with you and try and answer the questions along the way. So we thank you very much for attending, and we hope that you can please fill out that poll question at the end. And if you have any suggestions for future topics, we would love to hear them. Thank you very much.